Hello viewers, I am Kausalya. Today we are going to solve problems related with tuned circuit. So here the problem is consider the single tuned circuit shown in figure. Find resonant frequency, the output voltage at resonance and the maximum output voltage. So here assume Rs is greater than omega RL1 and the value of K is equal to zero point 0.9. So this is the given circuit diagram, right? And this problem is purely based under the formula, right? Once you know the formula, it is very easy. You can just substitute and find out the answers. So here first we start with finding the value of mutual inductance. So the value of M is given by K into root of L1 into L2. So here we have both the values of L1 and L2, right? And the value of K is directly given in the problem here. So just substitute and the value of M is 9 microhenry, right? And the first thing we need to calculate is resonant frequency. So here the resonant frequency is given by omega R equal to 1 by square root of L2 into C, right? So here we know the value of L2, we know the value of C. So just substitute the values here, right? You see here the value of L2 is 100 microhenry and the value of C is 0.1 microfarad, right? Here the micro denotes 10 to the power minus 6. So just substitute the values and the value of omega R is 10 to the power 6 by square root of 10 radians per second. So omega R, it is nothing but 2 pi Fr, right? So from this we can easily calculate the value of Fr. So the value of Fr is 50.329 kilohertz, right? So first part is over. So here the assumption is always, you see, omega or L1 is less than Rs. Rs is nothing but your source resistance here, right? So the value of omega or L1 just now we have calculated, right? So what is the value of Rs when you look back at the problem? So here Rs is nothing but your source resistance. The value of the source resistance is 10 ohm, right? So here this 0.316 is less than 10, right? So this condition is satisfied. So the next thing is finding the output voltage. Again, once you know the formula, you can directly substitute and calculate the values. So here the output voltage is given by M into Eg by C into R2 Rg plus omega R square M. Right. So just substitute the values here and finally the value of output voltage is 1.5 millivolt. Here we know each and every values, right? The value of R2, RG, C, M, EG. EG is your source voltage, right? So rest everything I believe you know. M is mutual inductance and C is the value of capacitor, right? So everything is given in the problem. You can directly substitute. That's it. And here the answer is 1.5 millivolt. And the next one is maximum value of output voltage. So again here, this is also based upon the formula. And this is the formula Eg by 2 omega Rc into root of Rs R2. So here again just substitute the values and finally the value of E0M is 23.7 volt, right? This problem gets over here. We will proceed with the next one. The next problem is for the circuit shown in figure, find the ratio of output voltage to the source voltage, right? So here this is the given circuit diagram. We need to calculate the output voltage, right? Because input voltage V1 is directly given. Once we calculate the value of V2, we can find the ratio of output voltage to the source voltage here, right? So here the first thing is we are applying KVL to both the loops, that is to the primary and the secondary. So when you write the expression here, it is, you see, I1 into R1 plus, so here I1 into R1 plus I1 into J omega L1, right? And here there is a mutual inductance. So whenever there is a mutual inductance, you have to consider the dots and you have to look at the direction of the current. So here for this primary loop, current enters at the dot point, whereas the secondary loop, you see, current leaves at the dotted point. So they are opposite to each other. So here it is. Then and again the mutual inductance in the primary is due to the current flowing in the secondary, right? So therefore the minus is due to the current direction opposite, okay, due to the opposite current directions. So minus I2 J omega M. Right, this is the expression here, which is equal to your source voltage, which is V1. Right. Now again, as usual, just substitute the values. Here in the primary side, we know the value of R1. Here the R1 is 10. And again here we know the value of L1, and L1 is also again 10, and the value of omega is 50. Right. And similarly here the value of mutual inductance M is 5, and again here omega value is 50. Right. So J and I2 remains as such. So just substitute, and the value of V1 is 10. And once you simplify, we are getting an expression like this. Right. Now we are going to apply KVL to our loop 2. So once you apply KVL, again the same thing. So here you see we are having I2 R2, and again here there is an L2, and again there is a mutual inductance. So just I2 into R2 plus I2J omega L2, right? And again due to the mutual inductance minus M into I1J omega, because the mutual inductance in the secondary is due to the current flowing in the primary, right? So here this is your expression, right? Minus I1 J omega M is equal to 0. So here again substitute the values. So once you simplify, here you see we are getting an equation like this, right? Now we are going to write it in the matrix form. So when you write it in the matrix form, you see there is a 2 by 2 matrix, right? I1, I2, and here which is equal to 10 and 0, because in the secondary there is no source voltage, so it is equated to 0 here, right? So here the thing is, I believe you people know how to write it in the matrix form, right? Here lies the coefficient of I1, and here is the coefficient of I2. Right, when you look at this equation, the coefficient of I1 is 10 plus J 500. So it is written here. And again coefficient of I2 is minus J 250, and here it is written here. Right. Similarly, when you look at this equation, what is the coefficient of I1? It is again minus J 250 here, and I2 is 400 plus J 5000. Right. So again the same thing, find out the value of del. Del is nothing but determinant of this matrix. So just with the help of calculator, you can easily calculate the values, right? So the value of del is calculated. Now we are going to find the value of del 2, right? So del 2 is, you have to replace the second column by the source values, right? So as usual, the value of del 2 is, when you multiply, here we are getting the answer as J 2500, right? So what we need here, actually we need I2. Once I2 is known, we can easily calculate V2. So the value of I2 is given by del 2 by del. So the value of del 2 is here, and the value of del is, we had already calculated, right? Again you can directly feed all these values in the calculator so that you can easily solve. And here the value of this I2 is given by this equation, and I have converted this into polar form, right? So now the next thing is, we are going to find the V2. So V2 is nothing but I2 into R2. So I2 into, here the R2 is 400, right? So once you solve here, this is your expression for V2, right? What we actually need, we need the ratio of output voltage to the input voltage. So V2 by V1. So here this is your value of V2, and the value of V1 is 10, right? It is given in the problem. So finally we are getting the answer as 40.8 into 10 to the power minus 3 with an angle of minus 84.13 degrees, right? Here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.